These are a couple of wax capacitors I just removed from a record player I'm working on, and we want to test. I'm just for the heck of it. I'm going to. I don't even usually test them, like I said. I just go ahead and remove them, chunk them, and put new ones in. That's my modus operandi. I do not want these old wax foil capacitors in the radios or whatever it is I restore. I want them gone. Some people say, "Oh, they're good." You can. No, not to me. They're not. Okay. So what we're going to do is I'll go ahead and let's find out if these were shorted. Matter of fact, I don't even own a capacitor checker other than what you see right here on this meter, and I've never used it. I just don't see any sense in checking them because I replace. So let's go ahead and I've got my my wires, my leads from my multimeter hooked to gator wires, so it'll make this job a little easier. Okay, now I've got this across both leads. Now you see the meter's not doing anything. Well, let's go up scale. Now we're at the 200 ohm scale. Let me close in here a little bit. Alright, let's go to the 2000 ohms. What we're doing, the reason we're not getting a reading here is because the resistance inside this capacitor is exceeding the scale that we're on. And when it exceeds it, it won't give you a display. It just stops cold. It took me a while to figure that out when, years ago when I was doing resistance readings on various things, just puttering around my car and everything. If you exceed the scale, it's not going to read. So you have to go to that next higher scale. Well, we're up to 20,000 ohms and it's still not doing anything. Now, most people would say, what's going on here? Is this thing dead? Or is this thing supposed to read like this? No, it's not supposed to do this. It's supposed to give you something, a zero or something. Let's go up to 200,000 ohms. Still nothing. Is it possible this thing actually exceeds 200,000 ohms? Well, let's find out. Let's go to the next level. 2 million, 2 megs. 2 million. Oh man, this is getting ridiculous. We're up there. Most people would say we're up there around 2 million ohms. Something may not be right here. All right, let's go to the 20 million scale. Aha! 17 million, 18 million, 19 million. Boom! It exceeded the scale, and once again, that's all we get. Okay? Now you know how to test capacitors. You should always test them on the highest scale and see what you get, okay? I'll tell you what, let's go ahead and test one of our nice new yellow ones on that same scale and see what happens. Remember, we're on the 20 million ohm scale, or 20 megohms. What do we get? We get nothing, okay? Nothing at all. It's good. That capacitor is good. There's no reading at all there. Now I can go all the way down, not getting a reading. It's open. It's wide open, and it's supposed to be open. These are capacitors. They're not supposed to be shorted between the leads. This one we tested is shorted between the leads, okay? You betcha. Tell you what, let's go ahead and test this second capacitor that I took out of that record player. See what happens. Let's go. We've still got it set to the 20 million ohms, the highest scale on the ohms. Okay. Let's go ahead and turn on the. All right. Let's watch what happens. Let's see it climb. How far will this one go? 14 million, 15 million, 16 million, 17, 18. It too exceeded the 20 million ohm scale. Let's do a little comparison between a really cheap Chinese-made Harbor Freight multimeter, and we're going to compare it to what the Fluke 73 says. And the best test I could think of was a 1 ohm resistor. A 1 ohm resistor. This is a brown and black are the two stripes, and that's the only stripes it has as far as valuation goes. Let's see what we get on the cheap Chinese-made. We get 2.1. What this meter is telling us, this cheap one, is that resistor is 100% out of tolerance. Let's switch leads and see what the fluke tells us. Alright, I've got the fluke gated in now on that 1 ohm resistor. Let's see what the fluke 73 tells us it is. 1.2 ohms, okay? Now which one you want to believe? This old cheap piece of crap here that I only use for, you know, quick resistance readings and a few voltage readings here and there. If it's off a little digit or two, it doesn't really matter, because I'm not doing precision work. But if you were going to do precision work, which one would you rather use? This one or this one? Actually, this is by far the best of the two, as you can see. This auto-ranging Fluke 73 that's many years old, been dropped who knows how many times, got cracked case and everything, still more accurate than this thing, which was just bought, you know, just a couple of years ago, and it's in perfect condition. Well, that's it for tonight. I think what I'm going to do, we'll save the rest of this video for tomorrow. And we'll fire up our little radio. We'll take a couple of voltage readings. We'll take a couple of resistance readings without power. Resistance is always taken with no power applied. You understand that? Yes. And then we'll go ahead and wrap it up, and hopefully everybody's learned something. The only thing I really want you to get out of this is, number one, there is a difference in meters. I never did really much like using digital until just a few years ago. I always liked the analog, you know, with the needle that moves. Seemed to work better for me, but the older you get, you find that your eyes start to, you know, fade away. It gets a little bit difficult to read those lines on those analog meters. You really got to get down and squint close, unless you have a great big, you know, meter, which of course I never did. And these large digital meters help me a lot, and they're easier to see in the videos that I show. So next time you see me, we'll have the radio set up, and we'll take a few voltage readings or resistance readings across a few components. And you know, someone always, I've gotten I don't know how many emails from people that said, John, do you read resistors in the circuit or out of the circuit? Then I've had some people tell me, well, you took that resistance reading of that resistor in the circuit. You should have lifted one end. Well, maybe, maybe not. You know, it depends on how it's situated in the circuit. We'll cover that in the next little segment here. Alright, with this segment we are down to the wire. What we're just going to do is, you know, take our little meter here. We're going to test a few things on the chassis of this radio we've been working on all this time. You know, check out a few resistors, maybe a coil. Anyway, getting back to the resistors, where I've said that some people have contacted me during the restoration series that I did over the years, and they said, you know, I've been told you're supposed to lift one end of the resistor, you know, you didn't lift the end of that resistor. Well, yeah, no kidding. You know, not all resistors need one end lifted. If you have a resistor, we'll say that's in parallel with a coil, well then, and you want to measure it, say from here to here, like so, well then yes, what's going to happen is you're not going to get an accurate reading. You're not going to read across that resistor, because electricity takes the least path of resistance. What's going to happen? It's going to read through the coil. It will not read through the resistor. So you'll wind up with something like 3 ohms instead of the 10K ohms you're supposed to get, okay? So in this case, you would have to lift one end of the resistor. Now keep in mind, not all resistors and coils that are in parallel are side by side like you see right here. Sometimes, let me move this schematic here. Let me get another pin. I had one here somewhere. Sometimes the coil is located clear on the other side of the schematic, okay? Sometimes you'll have a resistor. Come on, I ain't got no time for this crap. Okay, there we go. Sometimes you'll have a resistor like over here somewhere in your schematic, and you'll read across it. And it'll read like real low, and you say, wow, that resistor is bad. Well, you got to follow it out. You got to follow it out, see where it goes, both ends. Where do they go? Way over here in a switch somewhere, there could be a coil it's reading through. Just because it's here does not mean that there's not a coil in parallel with it here. Okay? They don't necessarily have to be located in the same place. Be sure to trace them out when you have a problem. And sometimes it can get pretty hairy with a very large schematic. All right. Well, let's take a look at this one here. suppose I took my the same thing, you know, there could be a capacitor located way over here in the schematic and the resistor way over here. You got to follow the lines. Suppose I went like this and I tested here and here across that resistor, and I'm looking for 150 ohms, and I only get, say, 1 ohm or 3 ohms or 10 ohms or 20 ohms. You don't know. What I could be getting here is I could have a shorted capacitor. Okay, so instead of reading down through the resistor down to ground down here, I would be reading through a shorted capacitor. Okay, like that. You never know what you're going to get. Always make sure that the resistor is isolated enough from a coil and from a possibly shorted capacitor that you can go ahead and read it in the circuit. Now, the last thing I'm going to leave you with on this is, if in doubt. Now, this is what I always tell these guys that, you know, call me down on measuring a resistor in the circuit. Look, guys, it's a simple problem, okay? It's not something earth-shattering here. If in doubt, lift one end out. You can lift the one end out on every single resistor in the entire chassis, no matter how large it is. It's up to you. It's your chassis, your reading, your resistor, okay? I just don't want you to get all bent out of shape, you know, and oh my God, it's the end of the world. He did not measure that resistor out of the circuit, okay? If you're in doubt, lift one end out. Let's take a few readings here in a second. Tell you what, let's just go ahead and start out with testing the cathode resistor. We're going to ohm it out on the output tube to 50C5, and it's supposed to be 150 ohms. Now, as you can see, it goes from ground across the resistor and into the tube. There's no connections inside the tube that connect to anything that would be in parallel with this resistor, giving us any kind of a parallel resistance. That baby is standing all by itself. So the way I see it, I should be able to go ahead and just I've got my negative lead connected to the ground on the electrolytic capacitors, which is right here. Move this baby around where you can see it. Right there. Back up a little bit. I just went ahead and connected the gator wire from the probe to the negative on the electrolytics. And now all I have to do, if all is righteous, all I have to do is take my probe and touch to the other side of that resistor, and I should get around 150 ohms. Now keep in mind, this radio's old. I won't get exactly 150 ohms. It'll probably be a little bit higher. Maybe a little lower. I don't know. We'll have to wait and see. Let's go ahead and touch there. That resistor I'm talking about is that brown. Is that one right there? Brown, green, brown. Okay, let's see if I can get a better focus. There we go. Now let's go ahead and touch the, it connects to that tube pin right there. Let's see what we're getting. 178, almost 179 ohms. Yep, it is a little high, okay? Now I just tested that one in the circuit, okay? Let me see if let me pick another one, and then I'll come back and we'll do it. All right, let's check this 2.2 megohm resistor that's in the ABC line that comes out of this IF transformer here. It comes out, it goes through the 2.2 megs, goes over. Remember now, this was the audio that was coming out of here along with the voltage. And the audio comes over here, and the audio goes through this capacitor to ground. We get rid of that. I don't see anything in parallel with that thing. Let's go up here and look up here. It goes up into a coil, through a coil. No, over to the control grid. Nothing there. Let's follow it around here. See if anything it doesn't go this way. It's a capacitor. That stops it. Up here, another capacitor, but it does go through the coil. Comes up to a capacitor. No, that would block it. Nothing in parallel there. We come up here, and the tuner, again, nothing in parallel. Let's shoot off over here. Nope, the trimmer cap would stop it there. Okay, so what happens is this thing is in fact isolated all by itself. Once again, all I have to do is connect one probe to one side of the resistor and a probe to the other side of the resistor, and I can read right through this one because it's not in parallel with anything. Okay, now I've already connected the negative lead to one side of that resistor. It's red, red, green. It's that one right there. It's well hidden. It's not connected to the electrolytic. It's just hidden down in there next to it, okay? And that antenna wire, by the way, that's an antenna wire. And that goes back to the tuning plates that I showed you right up here. Okay, it comes across and it goes up to the tuner. Okay, and that's where that wire comes from. Okay, now all I have to do is take my red probe and stick in on the other side and see how close to 2.2 megs we can get. Let me get down in there and touch it. Yeah, come on, baby. Where you at? There you are. Let's see if I can get to it. Alright, let's see what we get here. We're looking for 2.2 megs. Well, 2.7. That's not too bad. Alright, you see, what I'm trying to tell you here is you can read many resistors in the circuit. It just depends on how they're there. Now, there's one other thing I wanted to show you about in the circuit. I showed you the coil and the resistor. It could read down through the coil. It could read down to a shorted capacitor and give you the wrong reading. Sometimes you're going to run into resistors that look like this, okay? You want to read this one right here. Well, you know, you're going to have to lift the lead in a situation like this. And again, the resistor could be on one side of the schematic and the other resistor could be in the other. It could be at the top, it could be at the bottom. It could be on the side and the top. It could be on the side and the bottom. You have to, you know, follow the wiring out, okay? So in a case like this, you're going to have to lift each one. You have to lift one and then read it from there to ground. Then you'll have to read this one from here to ground or wherever it happens to be connected. And sometimes you'll see that this one is independent. You can go ahead and read it, but this one over here has a coil. This one over here might be in parallel with a coil coming across like this. Okay, and again, they could be, you know, positioned at both ends of these schematics. So you have to take your time when you're working on these schematics. Don't jump in there and say, oh my God, I'm getting the wrong readings. Oh, whine. Don't worry about it. Stop, take a deep breath, follow your lines out, and sometimes, you know, almost every time, you'll see that they're independently in the schematic and just go ahead and be read. Now, once in a while, you're going to, you know, you're going to give a reading. You're going to say, wow, I'm on a roll here. And then all of a sudden, you're going to say, wait a minute, you know, I'm not getting the right reading here. It doesn't seem like I'm getting the right reading. It doesn't look like it. I wonder. Well, that's when you're in doubt. So when you're in doubt, lift one end out, okay? Let's take a voltage reading and we'll wrap this up. Don't ask me how, but the old radio is still playing after everything we did to it. By the way, there's going to be one more thing I'm gonna cover here. I think it's important that you learn one more thing. We're going to go ahead and lift another capacitor end, and I'm going to let you hear the noise it makes one more time, and then I'm going to tell you what's causing it, okay? All right, I'll tell you what we're going to do right now, though. Let's go ahead. I got to be careful with this radio now. It is live. Don't be messing around with these things, reaching over the top of them, touching them with your arm, etc. Incidentally, one thing I see a lot of people do, I don't care what restoration video I go to, I don't care what repair video, people are wearing their watches and their rings. Standard safety practice from time eternal. You are supposed to remove watches and rings that are metal when you're working on electronic equipment. If you see a guy in a YouTube video who's wearing a ring and he's taking voltage readings, then he's not doing it right. He's not doing it right. I saw a kid one time reach up underneath a dash of a 55 Chevy, and he had one of those old-time, what they call Twistoflex watch bands. And he touched something up there, and it fried that watch band, burnt the leather off the outside, and put the impression of the Twistoflex watch band in that guy's wrist all the way around it. So it doesn't have to be electronics like these old radios. It can be even reaching up underneath the dash of a car. Be careful. Watches and rings are supposed to be removed when you're working on electronics or anything electrical. Trust me on that. All right. What we're going to do here is I am going to measure the voltage coming out of this C1A. I guess, yeah, C1A. It should be around 110 volts, okay? Then we're going to measure C1B. It should be about 90 volts coming out of these two electrolytics, okay? This resistor, remember, cuts the voltage down from around 110 down to 90. This little thing right here. It also acts as a choke, cheap choke, remember that. Alright, so the only thing I have to do to measure this is connect my black lead to ground, because both of those electrolytics are grounded on, you know, the negative side. And then I just flip my little old multimeter here. We're going to go ahead and put it on. I've got it set up for the 200 volt scale, alright, on DC volts. That'll cover the 90 and the 110, alright, 200 volts. Alright, let me go ahead and touch with my, again, I've got the black multimeter lead connected to negative on the capacitors, on the electrolytics. Let's measure the big one. Let's go with the 75 microfarads. This should give us about 110 volts according to the schematic. Let's see what we get. Oh my goodness, we're getting about 128. That's pretty high. That's pretty high, but I think that's because we have high voltage going in. Alright, now let's move over and touch right here to the positive of the 30 microfarad. We should get somewhere around 90 volts. That would be the small one right here. Touch the positive. 92.9. Okay, that's how you take voltage readings. You know, over here would be the same way. You know, I have a 90 volts here. All I'd have to do is leave my negative grounded, and then take my probe and stick it on the plate here of this tube. I can stick it on the plate here, where I'm supposed to have like 50 volts. Let me get this, get back up here a little bit. Starting to lose track here. There we go. That says 50 volts right there. So if I wanted to measure 50 volts, I would just, you know, touch my negative of my multimeter to ground, then just touch it here, you know, on pin 7. Where are you, darn it? Okay, pin 7, where I would go over here and touch pin 5, maybe 90 volts. Over here, pin 5 on the 12BE6, okay? That's how it's done. Just set your meter up to the scale. One more time. Each of these scales, like for instance, that scale right there that says 200 that I have my meter set to, 200 is the maximum voltage that scale can read. Once it goes beyond that, it'll blank out on you, okay? And then you say, well, I guess I better go up one more to the next higher scale. Same thing for resistance, okay? Now I'm going to do one more thing, and then we're going to shut this whole series down once and for all. Do y'all remember this sound from early on when we started this series? I'm turning up the volume here. Well, let me tell you what's causing that. That sound was generated because I lifted the ground off of C2 again. You'll remember that this is your ABC line that comes out of the second IF. The voltage and the audio comes down, and you know the voltage goes up and goes through here and creates a different bias on the control grid here, and it also, you know, it creates a different bias on the control grid here. The audio that's being carried along with that voltage goes to ground. They have to get rid of that, okay? Well, what I did was I lifted the ground. It goes through this capacitor. I lifted that ground, and of course the capacitor can no longer get rid of that audio. So what's happening is the audio is coming out of the second IF, coming down this way, coming up, and it's also coming up this way as well, and it's being recirculated. It's going around and around and around that audio because they can't go through the capacitor. The capacitor is no longer grounded. So what do we call that when it goes around and around like that and starts making screechy, crazy noises? It's called feedback. We generated feedback by that audio continually going around now. It has no other place to go. Your audio, you know, it's coming in on the antenna and it's coming up there and mixing with what's coming out of the oscillator, and it's just going round and round and round, making all kind of terrible noises. That's it. That's it. This series is hereby ended. Boy, I'll tell you what, I learned a lot. I hope some of you learned at least one thing. At least one thing. If you did, then the whole thing will have been worth it. Me, I learned a bunch. And I owe it all to my mentor, Brendan, no doubt about it. You know, he's the one that's been carrying the load on this for a long time. He's the unsung hero. You don't see all the emails that go back and forth. Anyway, I mean, if I have questions, I just fire them to him one after another, and he answers them. Anyway, this will be my last video until after the first. Well, I think I'm going to do one more video. One more video between now and after the first of the year. We'll be going to our sons for Christmas. I want to have at least one more video before we leave. So I appreciate everybody watching, hanging in, and for those that learned more than one thing, congratulations. You know, that's what this whole thing has been about. Anyway, until next time, thanks for being here and sticking with me. This is John.